The Antarctic Peninsula is the northernmost part of the mainland of Antarctica, located at the base of the Southern Hemisphere. At the surface, it is the biggest, most prominent peninsula in Antarctica as it extends 1,300 kilometers from a line between Cape Adams and a point on the mainland south of Eklund Islands, beneath the ice sheet which covers it. The Antarctic Peninsula consists of a string of bedrock islands. These are separated by deep channels whose bottoms lie at depths considerably below current sea level. They are joined together by a grounded ice sheet. Tierra del Fuego, the southernmost tip of South America, lies only about 1,000 kilometers away across the Drake Passage. The Antarctic Peninsula is currently dotted with numerous research stations, and nations have made multiple claims of sovereignty. The peninsula is part of disputed and overlapping claims by Argentina, Chile and the United Kingdom. None of these claims has international recognition, and, under the Antarctic Treaty System, the respective countries do not attempt to enforce their claims. Argentina has the most bases and personnel stationed on the peninsula. History. Discovery and naming. The first sighting of the Antarctic Peninsula by Europeans is disputed, but apparently occurred in 1820. The most likely first sighting of the Antarctic Peninsula, and also of the whole Antarctic mainland, was probably on the 27th of January 1820 by an expedition of the Russian Imperial Navy led by Fabian Gottlieb von Bellingshausen, but the party did not recognize as the mainland what they thought was an ice field covered by small hillocks. 3 days later, on the 30th of January 1820, Edward Bransfield and William Smith, with a British expedition, were the first to chart part of the Antarctic Peninsula. This area was later to be called Trinity Peninsula and is the extreme northeast portion of the peninsula. The next confirmed sighting was in 1832 by John Biscoe, a British explorer, who named the northern part of the Antarctic Peninsula as Graham Land. The first European to land on the continent is also disputed. A 19th-century seal hunter, John Davis, was almost certainly the first, but sealers were secretive about the movements and the logbooks were deliberately unreliable. To protect any new sealing grounds from competition, between 1901 and 1904, Otto Nordenskjöld led the Swedish Antarctic expedition, one of the first expeditions to explore parts of Antarctica. They landed on the Antarctic Peninsula in February 1902, aboard the Antarctica, which later sank not far from the peninsula. All crew were saved. They were later rescued by an Argentine ship. The British Graham Land expedition between 1934 and 1937 carried out aerial surveys and concluded that Graham Land was not an archipelago but was a peninsula. Agreement on the name Antarctic Peninsula by the US ACAN and UK APC in 1964 resolved a long-standing difference over the use of the United States' name Palmer Peninsula, or the British name Graham Land, for this geographic feature. This dispute was resolved by making Graham Land the part of the Antarctic Peninsula northward of a line between Cape Jeremy and Cape Agassiz, and Palmer Land the part southward of the line. Palmer Land is named for the United States seal hunter Nathaniel Palmer. In Chile, the peninsula is officially named O'Higgins Land, after Bernardo O'Higgins, the Chilean patriot and Antarctic visionary. Other Spanish-speaking countries call it Peninsula Antarctica, among them Argentina. It officially also refers to this as Tierra de San Martin, and Argentina has more bases and personnel wilder than any other nation. Other portions of the peninsula named by and after the various expeditions discovered them include Bowman Coast, Black Coast, Danko Coast, Davis Coast, English Coast, Fowler's Coast, Lubit Land, Northernmost Coast and the Wilkins Coast. Research stations. The first Antarctic research stations were established during World War II by a British military operation, Operation Tabrin. The 1950s saw a marked increase in the number of research bases as Britain, Chile and Argentina competed to make claims over the same area. Meteorology and geology were the primary research subjects. Since the peninsula has the mildest climate in Antarctica, the highest concentration of research stations on the continent can be found there, or on the many nearby islands, and it is the part of Antarctica most often visited by tour vessels and yachts. Occupied bases include Base General Bernardo O'Higgins Riquelme, Bellingshausen Station, Comandante Ferraz Brazilian Antarctic Base, Rothera Research Station and San Martin Base. Today, on the Antarctic Peninsula there are many abandoned scientific and military bases. Ice core and sediment samples from the peninsula are valuable because events such as the Little Ice Age can be verified with samples from other continents. Argentina's Esperanza base was the birthplace of Emilio Marcos Palma, the first person to be born in Antarctica. Recent tourism to the Antarctic Peninsula began in the 1950s. Most ship-based tourists depart for the peninsula from Ushuaia in Argentina. The grounding of the Argentine ship Bahia Paraíso and subsequent 170,000-gallon oil spill occurred near the Antarctic Peninsula in 1989. In 2005, Louis Gordon Pugh broke the farthest south long-distance swim record by undertaking a 1-kilometer swim at Petermann Island off the Antarctic Peninsula. In November 2007, the MV Explorer rammed submerged sea ice and then sank after water from a fist-sized hole could not be pumped out quickly enough. All passengers and crew were safely evacuated and rescued. Geography. The peninsula is highly mountainous, its highest peaks rising to about 2,800 meters. Notable peaks on the peninsula include Mount Castro, Mount Coman, Mount Gilbert, Mount Jackson, which is the highest point at 3,184 meters at 10,446 feet, Mount William, Mount Owen and Mount Scott. These mountains are considered to be a continuation of the Andes of South America, with a submarine spine, a ridge connecting the two. This is the basis for the position advanced by Chile and Argentina for their territorial claims. The Scotia Arc is the island arc system that links the mountains of the Antarctic Peninsula to those of Tierra del Fuego. The landscape of the peninsula is typical Antarctic tundra. The peninsula has a sharp elevation gradient, with glaciers flowing into the Larsen Ice Shelf, which experienced significant breakup in 2002. Other ice shelves on the peninsula include George VI Ice Shelf, Wilkins Ice Shelf, Werde Ice Shelf and the Bark Ice Shelf. The Filchner Run Ice Shelf lies to the east of the peninsula. Islands along the peninsula are mostly ice-covered and connected to the land by pack ice, separating the peninsula from nearby islands of the Antarctic Sound, Erebus and Terra Gulf, George VI Sound, Gerlachus Strait and the Lemaire Channel. The Lemaire Channel is a popular destination for tourist cruise ships that visit Antarctica. Further to the west lies the Bellingshausen Sea, and in the north is the Scotia Sea. The Antarctic Peninsula and Cape Horn create a funneling effect, which channels the winds into the relatively narrow Drake Passage. Hope Bay, at 63.383 degrees south, 57.000 degrees west, minus (63.383–57.000) is near the northern extremity of the peninsula, prime head at 63rd 13s, near the tip at Hope Bay's Shepherd Point. The part of the peninsula extending northeastwards from a line connecting Cape Cater to Cape Longing is called the Trinity Peninsula. Brown Bluff is a rare two-year and Shepherd Nunatak is found here also. The Erie, Seller, Fleming and Prospect glaciers form the Forster Ice Piedmont along the west coast of the peninsula. Charlotte Bay, Hughes Bay and Marguerite Bay are all on the west coast as well. On the east coast is the Athene Glacier. The Arktovsky and Eklund Nunataks are both just off the east coast. A number of smaller peninsulas extend from the main Antarctic Peninsula, including Hollock Canyon Peninsula and Pren Peninsula at the base of the Antarctic Peninsula. Also located here are the Scaife Mountains. The Eternity Range is found in the middle of the peninsula. Other geographical features include Avery Plateau, the twin towers of UNA's peaks. Climate. Because the Antarctic Peninsula, which reaches north of the Antarctic Circle, is the most northerly part of Antarctica, it has the mildest climates within this continent. Its temperatures are warmest in January, averages 1 to 2 degrees Celsius, and coldest in June, averages from -15 degrees Celsius to -20 degrees Celsius. Its west coast from the tip of the Antarctic Peninsula south to 68 degrees south, which has a maritime Antarctic climate, is the mildest part of Antarctic Peninsula. Within this part of the Antarctic Peninsula, temperatures exceed 0 degrees Celsius for 3 to 4 months during the summer, and rarely fall below -10 degrees Celsius during the winter. Farther south along the west coast and the northeast coast of the peninsula, mean monthly temperatures exceed 0 degrees Celsius for only 1 to 2 months of summer and average around -15 degrees Celsius in winter. The east coast of the Antarctic Peninsula south of 63 degrees south is generally much colder, with mean temperatures exceeding 0 degrees Celsius for only 0 to 1 months of summer and winter, mean temperatures ranging from -5 to -25 degrees Celsius. The colder temperatures of the southeast Weddell seaside of the Antarctic Peninsula are reflected in the persistence of ice shells that cling to the eastern side. Precipitation varies greatly within the Antarctic Peninsula. For the tip of the Antarctic Peninsula south to 68 degrees south, precipitation averages 35 to 50 centimeters per year. A good portion of this precipitation falls as rain during the summer on 2/3 of the days of the year, and with little seasonal variation in amounts. Between about 68 degrees south and 63 degrees south on the west coast of the Antarctic Peninsula and along its northeast coast, precipitation is 35 centimeters or less with occasional rain. Along the east coast of the Antarctic Peninsula south of 63 degrees south, precipitation ranges from 10 to 15 centimeters. In comparison, the subantarctic islands have precipitation of 1 to 2 meters per year, and the dry interior of Antarctica is a virtual desert with only 10 centimeters precipitation per year. Climate change. Because of issues concerning global climate change, the Antarctic Peninsula and adjacent parts of the Weddell Sea in its Pacific continental shelf has been the subject of intensive geologic, paleontologic, and paleoclimatic research by interdisciplinary and multinational groups over the last several decades. The combined study of the glaciology of its ice sheet and the paleontology, sedimentology, geology, stratigraphy, structural geology, and volcanology of glacial and non-glacial deposits of the Antarctic Peninsula has allowed the reconstruction of the paleoclimatology and prehistoric ice sheet fluctuation of it for over the last 100 million years. This research shows the dramatic changes in climate, which have occurred within this region after it reached its approximate position within the Antarctic Circle during the Cretaceous period. The fossil bluff group, which outcrops within Alexander Island, Antarctic Peninsula, provides a detailed record, which includes paleosols and fossil plants, of Middle Cretaceous terrestrial climates. The sediments that form the fossil bluff group accumulated within a volcanic island arc, which now forms the bedrock backbone of the Antarctic Peninsula, in prehistoric floodplains and deltas and offshore submarine fans and other marine sediments, as reflected in the plant fossils, paleosols, and climate models. The climate was warm, humid, and seasonally dry. According to climate models, the summers were dry and winters were wet. The rivers were perennial and subject to intermittent flooding as the result of heavy rainfall. Warm high-latitude climates reached a peak during the mid-late Cretaceous thermal maximum. Plant fossils found within the late Cretaceous strata of the Hidden Lake and Santa Maria formations, which outcrop within James Ross Seymour and adjacent islands, indicate that this emergent volcanic island arc enjoyed warm temperate of subtropical climates with adequate moisture for growth and without extended periods of below freezing winter temperatures. After the peak warmth of Cretaceous thermal maximum, the climate, both regionally and globally, appears to have cooled as seen in the Antarctic fossil wood record. Later, warm high-latitude climates returned to the Antarctic Peninsula region during the Paleocene and early Eocene as reflected in fossil plants. Abundant plant and marine fossils from Paleogene marine sediments that outcrop on Seymour Island indicate the presence of cool and moist, high-latitudes environment during the early Eocene. Detailed studies of the paleontology, sedimentology, and stratigraphy of glacial and non-glacial deposits within the Antarctic Peninsula and adjacent parts of the Weddell Sea in its Pacific continental shelf have found that it has become progressively glaciated as the climate of Antarctica dramatically and progressively cooled during the last 37 million years. This progressive cooling was contemporaneous with a reduction in atmospheric CO2 concentrations. During this climatic cooling, the Antarctic Peninsula was probably the last region of Antarctica to have been fully glaciated. Within the Antarctic Peninsula, mountain glaciation was initiated during the latest Eocene, about 37 to 34 Ma. The transition from temperate alpine glaciation to a dynamic ice sheet occurred about 12.8 Ma. At this time, the Antarctic Peninsula formed as the bedrock islands underlying it were overridden and joined together by an ice sheet in the early Pliocene about 5.3 to 3.6 Ma. During the Quaternary period, the size of the West Antarctic ice sheet has fluctuated in response to glacial, interglacial cycles. During glacial epochs, this ice sheet was significantly thicker than it is currently and extended to the edge of the continental shelves. During interglacial epochs, the West Antarctica ice sheet was thinner than during glacial epochs and its margins lay significantly inland of the continental margins. During the last glacial maximum, about 20,000 to 18,000 years ago, the ice sheet covering the Antarctic Peninsula was significantly thicker than it is now. Except for a few isolated nunataks, the Antarctic Peninsula and its associated islands were completely buried by the ice sheet. In addition, the ice sheet extended past the present shoreline line onto the Pacific outer continental shelf and completely filled the Weddell Sea up to the continental margin with grounded ice. The deglaciation of the Antarctic Peninsula largely occurred between 18,000 and 6,000 years ago as an interglacial climate was established in the region. It initially started about 18,000 to 14,000 years ago with retreat of the ice sheet from the Pacific outer continental shelf and the continental margin within the Weddell Sea. Within the Weddell Sea, the transition from grounded ice to a floating ice shelf occurred about 10,000 years ago. The deglaciation of some locations within the Antarctic Peninsula continued until 4,000 to 3,000 years ago. Within the Antarctic Peninsula, an interglacial climatic optimum occurred about 3,000 to 5,000 years ago. After the climate optimum, a distinct climate cooling, which lasted until historic times, occurred. The Antarctic Peninsula is a part of the world that is experiencing extraordinary warming. Each decade for the last 5, average temperatures in the Antarctic Peninsula have risen by ½ degree Celsius. Ice mass loss on the peninsula occurred at a rate of 60 billion tons in 2006, with the greatest change occurring in the northern tip of the peninsula. 7 ice shelves along the Antarctic Peninsula have retreated or disintegrated in the last 2 decades. Research by the United States Geological Survey has revealed that every ice front on the southern half of the peninsula experienced a retreat between 1947 and 2009. According to a study by the British Antarctic Survey, glaciers on the peninsula are not only retreating but also increasing their flow rate as a result of increased buoyancy in the lower parts of the glaciers. Professor David Vaughan has described the disintegration of the Wilkins ice shelf as the latest evidence of rapid warming in the area. The Intergovernmental Panel on Climate Change has been unable to determine the greatest potential effect on sea level rise that glaciers in the region may cause. Flora and fauna. The coasts of the peninsula have the mildest climate in Antarctica, and moss and lichen-covered rocks are free of snow during the summer months. Although the weather is still intensely cold and the growing season very short, the plant life today is mainly mosses, lichens and algae adapted to this harsh environment, with lichens preferring the wetter areas of the rocky landscape. The most common lichens are Usnea and Bryaria species, Antarctica's 2 flowering plant species, the Antarctic hairgrass and Antarctic pearlwort, are found on the northern and western parts of the Antarctic Peninsula, including offshore islands, where the climate is relatively mild. Legottolary Island in Marguerite Bay is an example of this habitat. Antarctic krill are found in the seas surrounding the peninsula and the rest of the continent. The crab-eater seal spends most of its life in the same waters feeding on krill. Bald-notodon is a cryopelagic fish that lives in sub-zero water temperatures around the peninsula. Vocalizations of the SEI whale can be heard emanating from the waters surrounding the Antarctic Peninsula. The animals of Antarctica live on food they find in the sea, not on land, and include seabirds, seals and penguins. The seals include leopard seal, Weddell seal, the huge southern elephant seal, and crab-eater seal. Penguin species found on the peninsula, especially near the tip and surrounding islands, include the chinstrap penguin, emperor penguin, gentle penguin and the Adélie penguin. Petermann Island is the world's southernmost colony of gentoo penguins. The exposed rocks on the island is one of many locations on the peninsula that provides a good habitat for rookeries. The penguins return each year and may reach populations of more than 10,000. Of these, the most common on the Antarctic Peninsula are the chinstrap and gentoo, with the only breeding colony of emperor penguins in West Antarctica, an isolated population on the Dion Islands, in Marguerite Bay on the west coast of the peninsula. Most emperor penguins breed in East Antarctica. Seabirds of the Southern Ocean and West Antarctica found on the peninsula include southern fulmar, the scavenging southern giant petrel, Cape petrel, snow petrel, the small Wilson's storm petrel, imperial shag, snowy sheathbull, the large south polar skewed brown skua, kelp gull, and Antarctic tern. The imperial shag is a cormorant which is native to many subantarctic islands, the Antarctic Peninsula and southern South America. Threats and preservation. Although this very remote part of the world has never been inhabited and is protected by the Antarctic Treaty System, which bans industrial development, waste disposal and nuclear testing, there is still a threat to these fragile ecosystems from increasing tourism, primarily on cruises across the Southern Ocean from the port of Ushuaia, Argentina. Paleofloras and paleofaunas. A rich record of fossil leaves, wood, pollen, and flowers demonstrates that flowering plants thrived in subtropical climates within the volcanic island arcs that occupied the Antarctic Peninsula region during the Cretaceous and very early Paleogene periods. The analysis of fossil leaves and flowers indicate that semi-tropical woodlands, which were composed of ancestors of plants that live in the tropics today, thrived within this region during a global thermal maximum with summer temperatures that averaged 20 degrees Celsius. The oldest fossil plants come from the Middle Cretaceous fossil bluff group, which outcrop along the edge of Alexander Island. These fossils reveal that at this time the forests consisted of large conifers, with mosses and ferns in the undergrowth. The paleosols, in which trees are rooted, have physical characteristics indicative of modern soils that form under seasonally dry climates, periodic high rainfall. Younger Cretaceous strata, which outcrop within James Ross, Seymour, and adjacent islands, contain plants fossil of late Cretaceous angiosperms with leaf morphotypes that are similar to those of living families such as Sterculaliaceae, Lauraceae, Winteraceae, Cunoniaceae, and Myrtaceae. They indicate that the emergent parts of the volcanic island arc, the eroded roots of which now form the central part of the Antarctic Peninsula, were covered by either warm temperate of subtropical forests. These fossil plants are indicative of tropical and subtropical forest at high paleolatitudes during the Middle and Late Cretaceous, which grew in climates without extended periods of below freezing winter temperatures and with adequate moisture for growth. The Cretaceous strata of James Ross Island also yielded the dinosaur genera Antarctopelta, which was the first dinosaur fossil to be found on Antarctica. Paleogene and early Eocene marine sediments that outcrop on Seymour Island contains plant-rich horizons. The fossil plants are dominated by permineralized branches of conifers and compressions of angiosperm leaves, and found within carbonate concretions. These fossils, which date to about 51.5 to 49.5 Mart, are dominated by leaves, cone scales, and leafy branches of Araucarian conifers, very similar in all respects to living Araucaria araucana from Chile. They suggest that the adjacent parts of the prehistoric Antarctic Peninsula were covered by forests that grew in a cool and moist, high-latitudes environment during the early Eocene. During the Cenozoic climatic cooling, the Antarctic Peninsula was the last region of Antarctica to have been fully glaciated, according to current research. As a result, this region was probably the last refugium for plants and animals that had inhabited Antarctica after it separated from the Gondwanaland. supercontinent. Analysis of paleontologic, stratigraphic, and sedimentologic data acquired from the study of drill core and seismic acquired during the shallow drilling on the Antarctic continental shelf, and other projects, and from fossil collections from and rock outcrops within Alexander, James Ross, King George, Seymour, and South Shetland Islands has yielded a record of the changes in terrestrial vegetation that occurred within the Antarctic Peninsula over the course of the past 37 million years. This research found that vegetation within the Antarctic Peninsula changed in response to a progressive climatic cooling that started with the initiation of mountain glaciation in the latest Eocene, about 37 to 34 Ma. The cooling was contemporaneous with glaciation elsewhere in Antarctica and a reduction in atmospheric CO2 concentrations. Initially, during the Eocene, this climate cooling resulted in a decrease in diversity of the angiosperm-dominated vegetation that inhabited the northern Antarctic Peninsula. During the Oligocene, about 34 to 23 Ma, these woodlands were replaced by a mosaic of southern beech and conifer-dominated woodlands and tundra as the climate continued to cool. By Middle Miocene, 16 to 11.6 Ma, a tundra landscape completely replaced any remaining woodlands. At this time, woodlands became completely extirpated from the Antarctic Peninsula and all of Antarctica. A tundra landscape probably persisted until about 12.8 Ma, when the transition from a temperate alpine glaciation to a dynamic ice sheet occurred. Eventually, the Antarctic Peninsula was overridden by an ice sheet, which has persisted without any interruption to this day. In the early Pliocene, about 5.3 to 3.6 Ma,